Right, today we go into subject 2. So we have app chapter for chemistry 2. We have done chemical bonding. So today we're going to go into gases. Go to gases. Yeah, and your test 1 will be covered chapter 1 to chapter 4. The test 1 will be in week 7. We are now in week number 3. So another 4 more weeks or 3 more weeks, you have to prepare for your test 1 already. Yeah. Okay. So this learning outcome is basically how we set the question. So basically, we will ask you the definition and also the important calculation, some formula. And when you get the answer, you need to know to explain what is that meaning, what is the meaning, value that you calculated, and so on. Or ask you to prove something. So just a reminder, your tests will have 2 tests. Each test have 10%. Assignment 15%. I will release assignment maybe in another two weeks. Already the question already done. So maybe I will release in another 2 weeks. Lab report, after you done the lab, you need to pass up 1 week. Final exam 50%. So just a reminder, you need 80% attendance to sit for final exam. Okay. So chapter 2 gases, we will learn some theory. Then the more important one is ideal gas law. And then some mixture of gases. So this one will come out in your test 1 and final exam. Yeah. So we start with some application in real life. We can transfer liquid from high position to low position by just having a siphon or having a straw mechanism, right? If you leave this, if you fill the straw with water, and with the difference of pressure or location, the pressure will press from one location to another one, making the liquid transfer from position A to position B. So we start with the understanding of pressure that will create some motion to the gases. Today we focus on gases, right? So gases, it link to 3 parameters: pressure, volume, and temperature. Okay, basically we play with these 3 the whole session. Yeah, we deal with pressure, T, we deal with volume, V, and temperature. Temperature, T, for throughout this module, we will use Kelvin, right? So in your test or final exam, just be careful. You need to convert Celsius into Kelvin. The question you will be given, I will set Celsius to trick you. If you use the Celsius value, then you get the wrong answer. Okay, so these are some highlights. So we start with the pressure first. So this one you already see. And also it works when you try to sip some water from your food or drinks. Yeah. Yeah. Okay. So we start with this one you read. So all these green color balls are to simulate the gases. So all these molecules, we already cover the molecule theory in chapter 1. So now we look in the bigger dimension. We look at molecule size. So this molecule will hit the surface and bounce back. So these are the fundamental, right? Yeah. So how pressure works? Pressure is basically, if you learn in physics, pressure equal to forces divided by area. Okay. So standard value for pressure at sea level you should already know it will be 101 kilopascal, right? Or the unit will be Newton over meter square is the same. So for this module, for your test or final exam, please use at least three meaningful numbers or at least 3 decimal place. Yeah, at least 3, but some question you need 4 for accuracy. Yeah, so this is some format for your answer, and with the unit, yeah, with the correct unit. So these are the things. Okay. So this one is in application of pressure in your normal daily life. So it just explain how you can draw water from the glass into your mouth. Right? So if you suck some water, so how water move from glass into your mouth is because of the difference of pressure. So you are creating low pressure in your mouth. Then the atmospheric pressure will press the drinks through the straw and go into your mouth. So this is how it works. Okay. This is just an introduction on how you transfer molecule of air or gases from one place to another one. You use the pressure force to push molecule of gases from one place to another one. Okay. And the direction of movement will be from high pressure move to low pressure. High pressure move to low pressure. Right. This one we read. Just a introduction. Right. Okay, the next question will be like what you learned in your SPM, or you'll be asked, right? So how much the maximum water can be pushed if you have exposed to external pressures, right? So how far, yeah? So you did some experiment with molecule and things, so mercury, right? So how we fill the straw, we need to create a low pressure. Perfect low pressure is a vacuum, right? Of course, it will be negative, but we use vacuum. So if we have vacuum in the straw, water can go up to 10.3 meter. So if you generate some vacuum here in the straw or in the tube, and you suck the air, become vacuum in 0 pressure, not negative, 0 kilopascal or 0 Newton over meter square, the height of the water will go up 10.3 meter. Right? So this will be the water height, water pressure at sea level, not sea level, at vacuum. So it means that this height of water will equal to the atmospheric pressure, that is 101,325 Pascal, or press will equal to the weight of this one. Right? The pressure is pressing here, making the water goes up 10.3 meter. So this orange color in the straw, this one, will create, you have a mass with gravity will pull. There's a force on the right hand side will equal to the left hand side. Okay. So when everything balanced, it's just saying that it's equal and so on. Right. So this one you learn. Okay. So this is the one is just an introduction on pressure. Is what you learn in your SPM. Now we go into theory already. Right. Theory is also another important part for your test and final exam. So we start with kinetic molecular theory or models for gases. So we start to work with some equation already. So you know that the state of air, when you draw molecule, the molecule is scattered, and they always bounce back because of energy. The molecule is bounced back when you hit the wall, and so on. It's like a snorkel, right? So when we apply kinetic, kinetic means movement of molecule. Kinetic means movement. Molecular theories, you have a few assumptions. One, it assumes the gases is a collective particles in constant straight line motion. So if you apply for kinetic mercury, molecular theory, we assume all these individual molecule, you move in a straight line. Straight line is like playing snorkel. You hit the wall and reflect back, reflect to a certain angle in straight line. Okay. Constant, why constant? Because in the real life, because an molecule will move because of energy. When you move, you consume energy. So sometimes it will slow down because of the energy, consumption energy. You hit and loss of energy, and then the velocity will slow down and so on. So this kinetic molecular theory is a theory in a perfect case. So you must have some assumption. Yeah. So second one is it do not attract or repel each other. Means you take away all the electromagnetic, electronegativity effect. You assume they do not interact, means they are inert gas. Do not have any reaction when they hit to another molecule. Means they do not join molecule together and so on. They just, all right. So they just go around and do not interact. So this is the kinetic molecular theory. Have two assumptions. Okay. And there is a loss of space. Means the space, the white color space here is too big compared to the molecule size. Mean in the free space. Yeah. And the average kinetic energy is related to temperature in Kelvin. Okay. So these are the four assumptions. Four assumptions. Okay. So first two assumptions will be one, it move in a straight line. Second, do not repel, do not attract. Third assumption, you have a loss of space. Number four, the energy is related to temperature. So temperature also means energy. So if you increase temperature, you give more energy, the molecule will move faster. Okay, so four assumptions, yeah? Assumption, kinetic molecular theory. Okay. So this is just a summary of what the four theories about. Okay. So in chemistry one, this is what you assume. In chemistry one, you assume that gases, they are compressible, means you're able to compress gases. Assume the shape and volume of their container means they take the shape and volume of the container. Means the gas will fill the volume of the container and have low density compared to the liquid and solid. This is what we learn in chemistry. These are the properties of gas when we talk about gases in chemistry. Compressible, they form the shape, they follow the shape of the container, and then they have low density compared to the state, liquid and solid. So if you press hard enough, gases, they will become liquid because molecule become nearer and nearer. And you press harder, it becomes solid. Okay, right? So compressibility, it just means that there's many space in between the molecules, so they're able to compress. Then liquid, the difference between gas and liquid is that liquid cannot be pressed anymore because there are little space. Liquid and solid is the same because no more space among the molecule. And for chapter 2, you start to see the word particles rather than molecule. If you see the question mentioned molecule means it's chapter 1 content. Right. So this is just some illustration. This one you read. So you read. Okay. So if this is just when you compress the gas into a can and you release it, it can fill a certain percentage of soda. So this is just an illustration. Okay. I won't ask you this one. Okay, so this is just a quiz check. Which statement is not consistent with the assumption of kinetic molecular theory? So just now we learned 4 assumptions, right? Which one is not consistent? Temperature increase, particle move faster, correct? Size of particle in gas should have dynamic effect on proportional of gases. So 4 assumptions do not talk about size, right? So gas have low density than solid and liquid. So C is correct. Answer is B lah. It's just answer. Okay, we have done assumption. Now we look into the pressure. Start to have something. Okay. So pressure, just now before we start the class, we learned about drawing drinks, liquid from glasses to your mouth. It's because of the pressure, right? So you know that in atmospheric, if you increase the height, the pressure is different. So in our Earth, we have a few layers, troposphere, stratosphere, and so on. So you have different pressure. And also from this chart, you can see there is a difference of temperature. So in the beginning, we say that we're looking at 3 parameters: pressure, volume, and temperature. So if you talk about atmosphere condition, you need to be careful on the height altitudes because it will affect your temperature. The temperature will affect the way of the gases behave. This is some information. Okay. All right, first equation, like what you learned in your physics. What is pressure? Pressure equal to force divided by area. The rest you read. Okay. P equal to F divided by area. Okay. Okay, pressure, some factor means numbers of gases or particles, means you feel more particles inside a container, means more pressure. So if in chapter 2, if we mention low pressure means less molecule. If we say high temperature, it means more molecule or more particles. Okay. So in the gases chapter 2, the effect of pressure or the pressure is actually a collision between gas particles that generate pressure. Okay, the rest you read. Collision, because of collision, you generate forces and area. Right? You take forces divided by area, you get pressure. So this also another chart that give you the altitude and the pressure. So as you move higher and higher, the pressure will reduce in atmospheric setting. And in Earth lah. Okay, this on atmospheric. Okay, important, the highlight in yellow. If you have lower pressure, it means you have lower gas particles in atmospheric setting. Okay. So when you climb to a higher altitudes, you suffocated, you feel you need more air. Why? Because you have less oxygen particles. Okay. For this region also, this one go in a bit into aerospace a bit. So when you take a plane, actually inside the cabin, there is a cabin pressure. The pilot will turn on the cabin pressure to pressurize the pressure inside the cabin so that you feel comfortable. If not, outside pressure will be very, very low. You're not able to breathe, and also very cold also. Right? Okay. So sometimes you feel something pain in your ears in the aircraft. Maybe because the pilot forget to turn on the cabin pressure mechanism, or sometimes there's a leakage of pressure inside the cabin. So you feel in pressure. So your lecturer, I myself is a scuba diver. So if you do scuba diving, you need to know how to equalize your ear if you go deeper in the water, right? So how you feel, or why you feel some painful when you go into higher mountain or go deeper in the sea, is because the different pressure between your outside of your eardrums and inside your eardrums. Yeah. So you can see here, outside your eardrum here is lower pressure. So you know that higher pressure will push to low pressure. It will push your eardrums. That's why you feel pain. Yeah. So this one you read. Okay. So if you see this diagram, you should be able to identify which one have the lowest pressure, right? So just now we only learned one simple theory statement saying that if you have low pressure, you have low particles. So the answer will be A lah. Huh? Okay, pressure unit, this is just a refresh. Pressure unit is Newton per meter, Newton over meter, because you take F divided by A, you know that force, unit SI for force is Newton, unit SI for area is meter square, so it's Newton divided by meter square. Or in other words, it also means Pascal, PA. So if the question asks you pressure, your answer need to put in Pascal or Newton over meter squared. Okay. And I think this is the first equation. Because in the test, you need to do conversion. 1 atmospheric means we use ATM will equal to 101,325 Pascal or Newton over meter square. Usually we straight away use Newton over meter square because the question will ask you the forces or area. Okay. So these are some conversion. Okay, the third unit will be in mercury. Mercury, if you see the question asks you to put in mmHg, Hg is mercury. So you need to convert into this height. Yeah. So just use back the understanding just now. There's a diagram. Ask you about the height of liquid. And there's a pressure that push from atmosphere. And atmosphere changes with height and temperature. So the higher the atmospheric pressure will push higher mercury height. Right? Okay, so I'll just give you an illustration. A standard atmospheric pressure, if you put in 1 atm, the standard height of mercury will be 760. Yeah? 1 atm equal to 760 mmHg. Yeah? So this is a standard value that you assume you know lah. Okay. Some textbook use mmHg is TORR, TOR. But for this module, TOR doesn't carry any meanings. I mean, it cannot help you to solve any question. Right? So sometimes the question, we will purposely put TOR to see whether you're able to convert back to mercury unit. Okay, so just now, a few minutes ago, we learned that at atmospheric pressure or at vacuum, we use a vacuum, seems similar setting as this mercury that we see on the screen here. In the tube also use vacuum, but exposed to atmospheric pressure. If the content inside the tube here is water, it will go up 10.3 meter. If you use mercury, it will go 10.3 meter. This one mercury is 0.76 meter. Right? So if you convert mercury, will be 13.5 times, but this one we just do some conversion. Conversion. If you study overseas in England or in Germany, they will use imperial unit, use inch for mercury. Or you refer to the old design handbook, sometimes they use imperial unit, inch mercury or pound per square. So this one, PSI is normally you learn in overseas, they will use imperial unit, right? This is just for info lah. So 1 atm equal to 29.92 inch mercury or 14.7 psi. So this one also important. 1 atm, 14.7 psi. PSI is important. Why? Because it's application in your daily life. It's a common sense. If you want to exchange your knowledge with other discipline, PSI is quite common. Okay. So you have this table in your tutorial sheet also. So this just for your reference lah. And this one at sea level. So in test, I won't ask you at sea level question. I'll ask you at different temperature or pressure level. Okay, so this is just a quick question. See whether you understand. To me, it's basically it tests your English level, right? You're playing with words. So in the place of mercury, a liquid is about twice as dense as water. Mercury is twice as dense as water used in barometer. With this barometer, normal atmospheric pressure would be about what? How many meter? Twice as dense as water. Water is 10 point something, right? 10.3, right? Meter. So double is, these are the calculation. So standard mercury density 13.6 gram per cm cube. So we know that in atmospheric standard pressure, mercury goes 760 mm or 76 cm. Why we use cm? Because the density, sometimes question will give you in gram over cm cube. You need to align or synchronize with the unit given. Okay. Water density is 1 gram over cm cube. So new liquid density, it tell you new liquid density is twice. So twice is 2 multiplied by water density. So it will be 2 gram over cm cube. So these are the steps that if the question come out, these are the things that we expect to see in your question. So first you need to state the standard condition is what, right? Or standard equation is what. Then you apply the equation. So we know that in your chemistry 1 or in your physics, you know that atmospheric pressure you can calculate, or pressure you can calculate that if you involve density, you involve height in the question, you will use P equal to rho GH. Rho is density multiplied by gravitational force multiplied by H. Gravitational force, right, is 9.81. So you need to balance, right? You need to balance left-hand side and right-hand side. So left-hand side will be, okay, so how to come to this equation, yeah? How to come to the rho H, because we remove rho GH, left-hand side equal to rho GH, second side, right-hand side. So left-hand side will be on the mercury, G, and this one will be on the mu rho GH. So we can simplify the equation by removing the G. So that's why in the PowerPoint slide here, you will see rho mercury multiplied by H here. So you substitute the value. So rho mercury will be 13.6 gram. Right? So if this question come out, you will see there's a density table at the back of the question in appendix. Yeah? Okay, you substitute, there's only one parameter missing, which is the H nu. You rearrange the equation, right? So I assume you have good mathematics. So the answer will be 5.17 meter. Okay, usually in tests, general equation will be have 1 mark. This one, 1 mark. The steps up to here will be 1 mark. The answer sometimes 1 to 2 marks. Okay. Answer without unit 0 mark. If the full mark for answer is 1 mark, if you forget to put the unit, you won't get the marks for final answer. If it's 2 marks, you only get 50% of the marks. With 2 marks, then you get 1. All right. So you find the closest answer lah. The closest answer is 1.52. Okay. So this is just of course in your test you won't see MCQ question, right? Okay, so we still continue with the pressure unit conversion. So just a recall. Now, for example, the question asks you to convert 0.311 atmospheric pressure to mm of mercury. How do you convert? Okay. You know that you need to write 1 atm equal 760 mm Hg. Or sometimes in question, your answer, you write this simple equation also have marks. Okay. So relationship, you write 0.31 mm multiply by the equation. You simplify the question, remove the atm, you'll get mercury height in mm. Okay, so in your answer sheet, we expect you to write the general equation, relationship first, or equation. Then you write 0.1331 atm equal, then your working steps, then your answer. This is the working step. No? 0.311 ATM multiply 760 mm Hg divided by 1 ATM. Okay. You need to show me how you cancel the unit in your answer. So for chemistry 2, your answer, you need to include unit. In the question, we'll keep on reminding you to include unit of measurement in your answer. Okay, this I think you've done. Okay, so if you understand this one, you should be able to do this tutorial question. If you have a bicycle tire, you inflate with a pressure of 125 psi, and this one is psi. Just now we learned 1 atmospheric equal to 14.7 psi. He asks you to convert this one in mmHg. So first, you write all the general equation first. He asks you about psi and mmHg. The relationship between them is atmospheric pressure. Right? So you write the general equation first. So solution map, you need to convert psi, convert to ATM, convert from ATM to mmHg. So you need to write the equation. Write equation, 1 ATM equal to 14.7 psi. And another general equation is 1 ATM equal to 760 mmHg. There are two equations, yeah? Then you write the working. If you don't know the pressure, you just can write X mmHg. Sorry, not this one. Can write 125 psi equal to working, and then your answer in mmHg. So this is your conversion steps. You can convert to how many ATM first. Then you can write how many ATM equal to how many mmHg. Okay, you can break into two steps. We've got two equations. Yeah? Okay. So these are the equations that we learned so far, and we apply in the tutorial question. This so far is still mathematics working steps. Nothing complex. Okay. Again, in your test, you need to show me how you cancel the units. Include the unit, and then you need to show me how to cancel the unit. How you arrive at the final units. Yeah. To be easier, I propose or I suggest you break into two steps, where you convert 125 psi into ATM first, then another ATM convert to mmHg. Okay, the final answer will be 6.46 10 power 3 mmHg. So in the chemistry 2, your answer, if you're able to write in the 10 power something, you write in 10 power something, and give your answer in 3 meaningful number, means 6.46 is 3 meaningful number. Or if you have 0 point something, give 3 decimal place, means 3 meaningful number. Okay. Okay, this is another one. With convert inch per Hg that I won't ask you in test. So this one just your exercise. Inch per Hg is also not what you practice in chemistry 2. So this one is just your homework. Just do. Right. Okay. Any questions so far? No, yeah? Okay. What we covered before 2.4 is the conversion of pressure. 1 ATM equal to what? Right? Now we start with law already. Means you come with the equation. So first we start with Boyle law. Boyle's law related P and V, pressure and volume. Yeah. Okay. P and V, yeah. So the rest you read lah. So in Boyle's law, assumption is important. In Boyle's law, temperature constant. If you want to use Boyle's law, temperature must be constant. You will learn 3 laws today. Boyle's law, you related pressure and volume at temperature constant. So later we come up with the thing. So Boyle's law mentioned if you have temperature constant and the amount of gas is constant, amount of gas here is your molar number. You have so how many moles of certain element. Pressure increase when the volume is decreased. So it's like a bicycle pump here. If you press the bicycle pump, the volume decrease, pressure increase. Pressure increase, volume decrease. If you decrease the pressure, volume increase. If you increase the volume, pressure will decrease. So by this statement, can you recall a mathematics relationship to relate P and V? P with B. What is relationship? You have linear relationship. You have inverse linear relationship. If you plot graph, so this one, if you put in mathematics, the rest you read now. So this is an illustration. Boyle's law state this one. Boyle's law state V are inversely with pressure, or in this case, for this class, I will focus on pressure on the left-hand side first. I'll fix the position of P on the left-hand side of the equation. So P, you can write P equal to 1 over V. Oh, sorry. P is inversely, you need to use the relationship of this one, proportional to this symbol. If the question asks you to use Boyle's law, you need to write this equation. You need to write Boyle's law, double dot, give me the equation. They consider 1 marks for understanding of the law. You don't need to write the whole grammar sentence in the test or final exam. You only need to give me Boyle's laws, then the equation. Okay, this one gives you 1 marks. You don't need to, this statement you don't need to write unless the question asks you to explain. Then you need to write the statement. Yeah. Okay. And so this will be the first law. Boyle's law. V inversely 1 over P, or in my case, I like to write P on the left-hand side of the equation. P inversely to 1 over V. Because later we'll combine the 3 laws, become one ideal gas law. If 2 quantities are inversely proportional, increasing one, decrease with another, this is just some observation that you see. If you get experimental, you will get volume. If you increase the pressure, volume will decrease. If you reduce the pressure, volume will increase. So this will be the experimental data. If you see V versus P, this will be the inverse graph. Okay. So if Of course, I won't ask you to plot, but as a future engineer, if you see something inverse something, y versus x, so you will see y equal to 1 over x, this kind of graph. Okay. Right. So how you prove Boyle's law? In SPM, there's a section of designing experiment. In our class, I won't ask you designing experiment in test or final exam, but you need to write lab report for your practical, right? So how you do? You use a U tube, the U shape of tube. Then you put in mercury. Then you close one end of the tube. Okay, open air. Atmospheric pressure. You mark the level, the mercury level in the tube. Then you add in mercury. Then you measure the height. Then you use the P equal to rho GH to find the graph. Okay. So this is just an illustration again, the Boyle's law. So let's say you have a container and the container give you 100 kilopascal. If you put more weight to press it, the pressure will increase, volume will increase. So here you can see if you have 100 kilopascal, the volume is 1 liter. If you increase the pressure, volume drop to half, 0.5 liter. Okay. So this is just an illustration. Different gases give you different value. Okay. So here in this Boyle's law, you just assume you have a general gas or ideal gas. Okay, so Boyle's law also use the word collision. Right? Collision. Boyle's law link collision with the pressure. Means the value of the pressure if higher, it means more collision happen. This is for the chemistry tool. This is the application of diver. So if you have at the surface sea level, your pressure pressing on your body is 100K kilopascal. And if you drop to 20 meter, the pressure will be 300 kilopascal. So this one is below sea level. Above sea level is another different things. Okay. So what does this mean for scuba diving or free divers? Every 10 meter of depth, if you link with the water, diver experience additional 100 kilopascal of pressure due to the weight of water surrounding the diver. So because you go deeper, more water pressing on your bodies, right? So at 20 meter, you have 300 kilopascal. Okay, so this also explains why in free diving, they don't allow you to go up surface very, very fast. Because in Olympic, you see some safety diver around the free diving, just to stop the diver from go to the surface too fast, right? So if you see here, if you go deep into 220 meter, the air that you suck into your lung, it must be equal. If not, you cannot breathe, right? So it must 300 kilopascal, and it's an external, well, same as your lung pressure. Okay, then you will see here. So if you go too fast, your inside, your lung actually is like a water tank, right? So it will hold the pressure at 300 kilopascal. If you go too fast, the pressure outside your body, if let's say you go to the surface, is about 100 kilopascal. What happened? Which is the direction of gas will go from 300 go out to 100 kilopascal. So you imagine oxygen will go from your lung very fast to atmosphere, to outside. So you imagine molecule of gases is very, very small. It will go out, means it will hurt your vein and so on. Okay. So this is just some this one. So you just direct read. Right. So in diving, don't hold your breath lah. So if you are in free diving, the most rules that all the coaches will tell you, do not hold your breath. If you hold, means you contain the pressure. You carry the pressure from a certain depth to surface. It's very dangerous. Right? It's like open a Coke. Right? Okay, a few more slides, then we go for a break. Okay, in mathematics, we need to convert this proportional sign into a equal sign so that we can do calculation. So when we do conversion in mathematics, we can write V equal to a constant value of P. Or in my case, I will convert P equal to a constant value of V. Yeah, so this is the first equation before we go to the break. This is mathematics lah. You learn in physics or you learn in other mathematics. You convert the in proportional symbol into equal, you need to put in constant. Or in engineering, we like to put in the linear form. We like to see equation in linear form. So we write PV equal to a constant. Constant, you can put C. In test, if you use any symbol other than the PowerPoint slides, you need to tell me what is that. Okay. Okay. So if you're comparing two scenarios, you use PV equal to constant. Because it's constant, you're able to compare scenario 1 and scenario 2 by using this equation. PV first set equal to PV second set. 1 refer to scenario 1, 2 refer to scenario number 2, by assuming you are using the same apparatus, same gases, and same condition. And again, Boyle's law, there's one constant cannot change, which is the temperature. Temperature must be constant if you want to use this equation. Very easy to see whether the question asks you Boyle's law. You will see temperature, assume temperature constant. Find pressure or find volume of a certain gas. Means it will sure go to Boyle's law. It asks you to use Boyle's law actually. The question won't mention Boyle's law, but it will give you some hints. If the question mentions temperature constant, find pressure or volume. One of the component will be missing, so you need to use the correct equation. Okay. Application of how you use P1 V1, P2 V2. It asks you calculate the pressure of gas that initially, you'll see initially at 120 kilopascal, 178 liter. So you'll see liter here. Later on, you will see other unit. 1 liter equal to 1 meter cube equal to 110 power 3 cm cube. Sorry. 1 power, correct. Yeah. We deal with liter first. So we ask you to compress to 1.25 liter. So you're having pressure and ask you to find another pressure. So you just substitute the value inside there. 102 kilopascal is P1, 1.78 is V1, 1.25 liter is V2. So there's only one parameter missing in the equation. Rearrange and you get the equation, yeah? So again, write the general equation first, then substitute the value, rearrange the equation, and remember to put in unit into your working steps. Remember, put in the unit and then demonstrate to me in your answer how you cancel out the unit. In this case, liter cancel, you arrive at kilopascal. Okay, this is how you work lah. Okay, nothing complex here. Okay, we will continue with this tutorial question after the breaks. Okay, we have 10 minutes breaks. Continue 12:10.